Good morning, good afternoon, and good evening. Welcome to the presentation of Multimodal Conversation, version 2.2. So this is one of the first standards approved. It had already had several versions, and now we want to present the version. But before that, two words about MPAI, moving picture audio and data coded by artificial intelligence, international unaffiliated not-for-profit standard development organization. We develop AI-based data coding standards, but we add a clear intellectual property right licensing framework. So two words about this last point. The goal is to make standard accessible and timely available. We do that with the following three steps. Before initiating a standard, a framework license is defined. And this, we call it license, but actually it is not a license because it does not include values, does not include dollars, percentage dates, and so on. But it declares that the eventual license will be issued at a price comparable with similar standard technologies, not after products are on the market. During the development, any member making a contribution declares it will make its license available according to the framework license. And after the development, members holding IP in the standard select the preferred patent pool administrator. And so this is entirely in the hands of patent holders and not in the hands of MPAI. How do we develop standards? So standards are very tricky things. Process must be clear, must be open to members, of course, and it must be rigorous. So we are probably exceeding in rigor because we have 8 steps that allows us to move from an idea through functional requirement, commercial requirement, call for technology, standard development, community comment to the final version of the standard. So what is specific of MPAI standard? This is obviously very much relevant to the presentation that you will hear today, is that the MPAI data coding standard make explicit the computing workflow of AI applications. And MPAI standard breaks up monolithic application, AI application, into a set of interacting components where we try to give as much as possible node semantics. Developers using standard can compete offering improved performance standards component, not necessarily the big system, which sometimes may be not within reach of medium to small enterprises. And humans can select application whose internal operation they can somehow understand. So the summary is that our standards are component-based. And an AI application is subdivided in smaller components called AI modules, aggregated in one or more AI workflows, and executed in a standard environment. You will hear this word and you will see this word later during this presentation. So all this is contained in one foundational technical specification called AI framework. So this is a small introduction to the AI framework. So you see that we have an environment, and that is an AI workflow that includes AI modules. You see that there's a controller that, of course, oversees the execution of the workflow, but we also have access to several API, including security API. This was in addition to made it when we developed version 2.0. Another important point is that whenever there is a standard, in the case of MPAI, we have a collection of standards, an ecosystem is created. And the ecosystem is composed, yeah, of course, by the fact that there is a standard. So MPAI is part of the ecosystem. Developers develop the components. Then you have integrators that may take a smaller component and integrate it into bigger components or application, and consumers who use the assembled components via the application. MPAI has identified the need for an entity guaranteeing that the components are interoperable, trusted, and available. And that entity is called MPAI Store. It exists, and you will hear more about that in the future. All this is contained in another foundational technical specification, governance of the MPAI ecosystem. So I talked about the ecosystem. What is this? So more or less, you have a graphical representation of what I've just said. We have the developers developing implementation. Then we have performance assessor. These are entities appointed by MPAI, and they make an assessment of implementation and give say, in this case, we say okay, but it's not necessarily an okay. It can be just a number that says how good an implementation is. Then we have the MPAI Store, and that the implementer submit the implementation to the MPAI Store, which verifies the security, tests conformance, and checks the performance. Finally, the implementation are posted on the MPAI Store website so that users can download the implementation and report their experience score, of course, if they want. So this is the MPAI organization, which is certainly a large one. Yeah, we have the General Assembly that, of course, controls the important work. We also had the board of directors, but this is more in the background. So we have standing committees, and we have development committees. One standing committee is the requirement standing committee, which is the place where work starts, and then we have development committees where the standards are actually produced. So, and this is what MPAI has delivered so far. We have 13 standards. We have a few, they are indicated in italic, that are being developed. And the multimodal conversation is the one that will be presented today. It's a major standards, and because of that, it's my time to give the floor to Milan.
This is the table of contents of the new MMC version 2.2. So as usual, there is a forward introduction, scope, and definitions, references, and the important parts are AI workflows, AI modules, data types, and data sets. Okay, now the scope of this new version is the specification of data types. Those are 23 data types for use by the MPAI MMC version 2.2, and they are also shared by other MPAI technical specifications. And the 23 AI modules that enables analysis of text, speech, and other non-verbal components, which are used in human-machine and machine-machine conversation applications. And then 8 AI workflows, and those are the new use cases for this new version that implements use cases that use AI modules and data types from MPAI MMC and other MPAI technical specification to provide recognized applications in the multimodal conversation domain. So some workflows are shared by other standards too. Okay. So these are the data types and that are used in version 2.2. So there is personal status and speech object and speech overlap, and those are emphasized by red color, text segments and text words. So maybe I can show you the one of those. Maybe a speech object. So can you see my the browser? Yeah, maybe not. Okay, so yeah, if you click this data types, you can see the structures and the features. Okay, so I'll go over the to the next page. Okay, so for example, the person status data type. So this is the data types, including three personal status factors like emotion and cognitive state, such as surprised or interested, and the third one is social attitude, such as polite or arrogant. Each factor can be conveyed by modalities like text, speech, face, and gestures. And the factors are represented by descriptors. For example, when using speech, the elements may be expressed by combinations of prosody, like pitch, rhythm, and volume variations. Several speech effects, such as degrees of voice tension, breathiness, etc., and vocal gestures, like laughs, sobs, etc. Okay. So that's the personal status. And here's another explanation. Each factor has two tables. So for its emotion and cognitive state and social attitude, has a label set table that has descriptive labels relevant to the type in three columns, like categories, specifies the relevant categories using nouns, such as anger, and general adjectives that specifies adjectival labels within a category, like angry, and specified a specific adjective column that shows the subcategory labels in the category, like furious. And another table is a label, a semantics table that provides the semantics for each label in the general adjectival and specific adjectival columns of the label set table. So, for example, the semantic loss of angry is emotion due to a perception of physical or emotional damage or a threat. So that explains the angry. Okay, so this is a sample of the basic cognitive state label set. So the cognitive categories shows arousal, attention, belief, interest, and so on. And general adjectives for the arousal, aroused, excited, energetic. And specific adjective shows cheerful, playful, lethargic, and sleepy. So each cognitive categories has general adjective and specific adjectives. And this is a basic cognitive state semantic set. And those are some sets, samples. So for example, the aroused, excited, energetic, that's a cognitive state. And meaning is the cognitive state of alertness and energy, and so on. Okay, so those are the explanation, the meaning of the cognitive state. And here is a table for the MMC version 2.2 AI modules. So we have several of AI modules. So some of them are in the first version of MMC, and yeah, most of them are extended or more developed in this version. So for example, ASR is automatic speech recognition module, and entity dialogue processing module, EDP, and SIR, speaker identity recognition, and so on. And those are expressed by JSON. Okay, so first one, so we would like to introduce some of the AI modules, like automatic speech recognition. So that's we called it ASR, MMC ASR in version 2.2. So the inputs are various, like language selector, auxiliary text, speaker ID, and speech overlap, speech object, and speaker time. So those are the input to the AI module of ASR, automatic speech recognition. And then it produces as output text segment. Okay, so inside this box, there's a method to recognize the speech automatically. Another example of the AI module is entity dialogue processing. Okay, so the input, like a summary, text object, meaning, personal status, and so on, goes through this AI module, which is entity dialogue processing. So that produces a summary of the dialogue processing and machine text and machine personal status. Okay, so it means the machine interprets the inputs, and then it prepares the correct answers or responses as a summary or text with the machine personal status. Next AI module is a speaker identity recognition that recognizes the speaker's identity. So it takes the input, auxiliary text, speech object, speech time, and so on, and it processes it to find the speaker ID of the speech. So the output of this module is the speaker ID. And the next one is the speech translation with the descriptors, MMC STD. So it takes the language selector, language speech object, and speech another speech object, and there are three AI modules. So this is a composite AI modules. So entity speech description takes the speech object, and it produces speech descriptors, and the automatic speech recognition produces a recognized text, and then the text-to-speech with the descriptors AI module produces as output the translated speech. Okay. So this is text-to speech translation with the descriptors. And this is text and speech translation. Okay, this is the TST. So it takes the input, and on the left side, okay, like input text, speech, and feature selector. And if you see on the right side, all the output is produced as translated text and translated speech. And in the box, you will see 4 different AI modules, like ASR. So it takes the speech to produces recognized text. And there's a text-to-text translation and entity speech description. So the output goes to the descriptor's text-to-speech, and then finally it produces the translated speech. Okay, and here are the AI workflows for version 2.2. So you see the 8 here, and those are the answer to multimodal question, conversation about the scene, conversation with personal status. And the red ones are introduced in this presentation. So this is the workflow answer to multimodal question. So actually it produces answers to the people or machines question. So usually we call it question answering technology, but here we call it answer to multimodal question. Okay, so the input is speech object, visual object, and text object. And it goes to automatic speech recognition, and text object is produced and based on the text object and visual object and text object that are input to text and image query. It produces text object, okay, to the output side on the right. So text object can be produced as text itself, or it goes to text to speech, TTS, and it produces speech object, so you can hear the answer as a speech. I think this is a human car interaction, very complicated one, but still we have some inputs on the left side, like text, audio, and visual, and it goes to audio-visual scene descriptions. So it describes the scene or environment. Okay, so it goes to some sub AIMs like automatic speech recognition and visual object identification, and then it finds what is in the scene and visual object ID, and recognize text and visual scene descriptions. And through the natural language understanding, it produces a meaning to the personal status extraction. And it also, the speech by speech object, we can see the speaker ID recognition. So you can understand who is speaking. And then there is also face ID recognition module, so that you can see who is talking. So you can find the face of the speaker. And that all the output from the previous ones goes to entity dialog processing. So it produces the machine personal status, such as emotion and cognitive status. Okay, and there's also machine text. So it goes to the personal status display, and it produces the machine portable avatar, so we can see what's the machine's personal status and what it is speaking. Okay, so that's the there's a audio visual scene rendering AI module. So it produces the text, speech, audio, visual. So we can have the conversation with the car, and there is a interaction between the remote cars, connected cars, and there is some HCI messages coming from other cars. Also AMS HCI messages. So that's the autonomous motion subsystem. So this whole picture is about the car and the human interaction. So finally, there is another workflow, which is called a virtual meeting secretary. So this is MMC VMS. Okay, so this is for the conferences. So there are some portable avatars, goes to the portable avatar demultiplexing, and then there's a input speech and input text, and also natural language understanding, and then we extract the personal status extraction for the avatar ID and input personal status. So the conversation among the avatars, among the participants, are captured. And then the virtual meeting secretary will make a summary of the conversation in the conference. So this is a summary creation module. And then so it produces a summary based on the avatar's speech and the text. And also it considers input personal status. Okay, so the summary goes to the entity dialog processing. And also the meaning and text goes to the entity dialog processing, so that we understand what's going on and what is said in the conversation and conference. And there is also the edited summary goes back to the summary creation module. And there's the loop between the summary creation module and entity dialog processing, so that finally the virtual meeting secretary can make the summary of this conference. So this VMS, the virtual meeting secretary avatar model will go to the personal status display, and also the VMS text will go to the through the personal status display, and finally the summary will be produced as a output with the VMS portable avatar. Okay. And we are preparing for the compromise testing. So for example, for the data types on the left, text, speech file, video file, and so on, we made some characteristics that should be confirmed. So for example, the text file shall be composed of Unicode characters. The speech files shall be conforming .wave files, and so on. So these are the requirements for the data types conformance testing. Okay. So our feature. So what is next of the MMC? So MMC standard is a living standard because it also serves the needs of several MPAI standards areas. And more versions MMC are anticipated with more use cases, AI modules, and data types. And we are going to develop conformance testing for all data types, AI modules, and AIWs. Okay, so we look forward to working with you. Please join us in MPAI.